In this video, we'll be using the TI-84 Plus Silver Edition graphing calculator to find the GCD, the LCM of given numbers, and also we'll look at how to find the location of any maximum or minimum of a given function. So first, let's look at the method for finding the GCD. So we'll go to Math here, then over on the top, get the number menu, scroll down to GCD. So that's number 9, hit enter. And then just enter the numbers you want to find the GCD of. The GCD stands for the greatest common divisor, also known as the GCF, or the greatest common factor. Okay, so we're looking for the largest number that divides, say, two numbers. So we'll look at, say, 14, comma, 24. Close parentheses. Okay, and these are small numbers, so you could probably do this in your head, but just to show you that the calculator does give you the correct answer, hit enter here. And 2 is the largest. Okay, if you pick, say, something different here. Let's look at math. Over to number. And number 9, again, GCD, greatest common divisor. Let's enter 7, comma, 9. Okay. Well, you can see there that the largest number that will divide 7 and 9, again, we're looking for positive numbers here, is 1. Now, if you're looking for the GCD of 3 numbers, look at math again, over, and then 9. Say we want GCD of, say, 12, comma, 24, comma, 36. Hit enter. Gives you an error. Okay, so the way it's set up, unless you make an adjustment, it'll only do 2 numbers at a time. Okay, so if you want to do 2 numbers, you'll have to use the little technique here. Go to math, over to number, again 9, and say we want the GCD of 13, 39, and 182. Okay, obviously we know that if we put all 3 the way we did previously, it'll give me an error. So what we can do is this: go to math, over to number, again number 9. Okay, so we have, again, we put GCD and enter the numbers here. So let's put any 2 will work here first. So we'll just give the 13, comma, and then the 39. Okay, close the parentheses here. Okay, and then put a comma, and then enter the third one, which is 182. Close the parentheses. So we're looking for the largest number that will divide 13, 39, and 182. So if you set it up this way, it should work. Hit enter, and it's 13. 13 is the largest number that will divide 13, 39, and 182. Okay, and you should probably be able to do it if there's 4 numbers. Using a similar technique. Let's clear this. Now we're going to look at how to find the LCM of 2 numbers. That's the least common multiple, or lowest common multiple. Pretty much the same thing as when you're finding the lowest common denominator when you're adding fractions. So in this case, let's just do one with 2. So we'll go math, over to number, and LCM is number 8. You can scroll down this way or just enter 8. Here, just hit enter, it's highlighted there. So let's say we want the lowest common multiple or lowest common denominator. Say you had the numbers 12, comma 24. Okay, lowest common multiple. In this case, we're looking for the lowest or the smallest number that 12 and 24 will divide. Okay, they'll have to divide it. So hit enter, and it's 24. You can see 12 into 24 will go 2 times. 24 into 24 will go once. Okay, that's the one you want. Okay. Now, if you want the least common multiple of 3, again, it's going to give you an error if you just enter them. So you'll have to do something similar to what we did in the previous problem. So we go to Math, over to Number, and then number 8, and then access that again by going to Math and 8, and then we enter the numbers. So doesn't matter which two you do first. So 13, comma 39, then close the parentheses, then a comma, and then into the third one, 182, close parentheses. Okay, so we're looking for the smallest number that 39, and 182 will all divide into. Hit enter, and that number is 546. Okay, let's clear this. Let's go to Math, and then scroll down to this one, 6F minimum. Now, if I hit enter, and you enter a function and an interval, this will compute the location of the minimum for that particular function. It could be a cost function, and it'll give you the location where the minimum cost is located at. Or if it's a maximum, which we'll look at later, it'll give you the location where the maximum value for that profit function exists. So you simply enter the function. Okay. So in this case, I suppose we have x squared minus 4x plus 11. Okay, then we put a parentheses. So this is f of x is equal to x squared minus 4x plus 11. Okay, which you should recognize it as a parabola or a quadratic function. The next thing you do is you indicate the variable. Okay, obviously it's x. Okay, got x squared minus 4x, so we enter an x. Okay, and then a comma, and then we want to give the interval. Okay, so let's say we're dealing with cost, so we know the answer has to be greater than 0. So let's select the bounds. The lower bound would be, say, at 0, and then comma. We can go to 3 or 4, something we kind of know that the function will be in between. So let's enter a 3, and then close parentheses, and hit enter. Okay, so this tells you then that to expect a minimum at the point, or at the value where x is equal to 1.999. You can actually run that out to 2. Okay, so what I'm going to show you now is what this thing looks like if you graph it. Okay, so let me hit the y equals here. Okay, so this is the one we just looked at. It's x squared minus 4x plus 11. Okay, so let's hit graph. Okay, so there's your parabola. Okay, so notice there's a 0 and then 3 somewhere over here, and right in here at x equal 2 is where the minimum value occurs. Okay, so notice if I go to the right of 2, the graph goes up here somewhere. If I go to the left of 2, over here at 1, it's up here, right here. So you can see from the graph that the smallest value of y, okay, of the function, is from where we have x equal to 2 right here on this line, and you go up this distance right here would be the minimum. Okay, so let's look at the table in case you can't make it out from there. Look at the table second, and then hit graph, which we're accessing the table. So let's see what happens here. You can see at x equal 2, the y value is 7. So that's telling you that the minimum value of this particular quadratic function occurs when x is equal to 2 and y is equal to 7. In other words, that's the vertex. That's the vertex of the parabola. So this could be values of x in the hundreds, values of y in the thousands. Okay, so you could say the minimum cost of this cost function occurs when x is equal to, say, 200 units, and the minimum cost is 7,000. Okay, or it could be 70,000 depending on what unit you're working with. Okay, so that's what this function gives you. Now let's go to math, and now I want to go down to number 7. F maximum. This does the same sort of thing, but now it gives you the location where the maximum is. Okay. So let's clear this, and again, let me go back to math. Now we want maximum. Okay, so I hit enter. And I'm going to enter the function here. This function is going to be minus x to the second plus 6x minus 4. Okay, again, we're looking at a quadratic function, or the graph will be a parabola. Put a comma here, and again, you have to tell the calculator the variable you're dealing with. Obviously, it's x, so we put an x there, and then again a comma. And then again, I'm going to say the interval. Again, it's going to be from, since we're dealing with, we're going to be dealing with money here, so 0, comma, I'm going to say 10. Play around with this, close parentheses, and then see what this gives me. Hit enter. Okay, so it tells me that the maximum value for this function occurs at x equal to 3.0000. Okay, so that's another way that the calculator is telling you that the value is actually 3. Okay, and you can see that more clearly if I look at the graph of this. Okay, so that would be the second one that we're looking at here. So let's go over here and deselect this one. Okay, so I want to graph this one right here. Hit graph. So notice again we have a parabola. This one opens down. So if I go to this point right here, which looks like it's 1, 2, 3. See? Okay, so that's what we got from the calculator. This tells me that the maximum value occurs when x is equal to 3. Now that could just be a regular 3, or it could be in hundreds. Okay, 300, or it could be in thousands. That could be 3,000, depending on what they give you. And then the maximum value is actually the distance from this point to the vertex. Okay, so in other words, when you're dealing with quadratic models like this that could represent cost or could represent profit, the answer is going to occur at the vertex. The number of units will be the x component, and the cost of the profit will be the second component. So let's look and see what this gives us here. If I go to the table, hit second, and then here. So if I go down, okay, the value of x was 3. That's where the maximum of that function occurred, and notice we get 5. Okay. So if they ask you at what value of x does the maximum value occur, could be maximum profit, you would say that x equal to 3 units. And then if they ask you what is the actual profit, okay, you look at the y value, and that would be 5. Okay, maximum value is 5. If you're just looking at a regular function, the maximum is 3, x or y equal 3, and it occurs at x equal 3. If you're dealing with money, this could be a profit or a cost function. Then you give the answer in units over here for the x, and in dollars over here for the y. So in this case, the location of the maximum is at x equal to 3 units. Okay. Thanks for watching. We'll see you next time.